All right, let's consider our next example. Write a loop that computes a vector y that contains the signs of the elements of x. To test your loop, write a script that A uses Linspace to assign to x a vector with 100 elements running from 0 to 2 pi. B uses your loop to store the signs in y. And C plots the elements of y as a function of the elements of x. So as a precondition for the script, we're going to have a vector x, which contains angles and radians at which we'd like to evaluate the sine or compute the sine of that angle. We're going to store all of those signs in a vector, and then we're going to plot sine versus the corresponding angle. All right, let's go to Matlab and give it a try. Okay, so here I am now over in Matlab. So let's go ahead and create a new script. And so this script, so we are going to plot sine over the range. So actually, this would be sine versus angle over the range 0 to 2 times pi. Okay, excellent. This would be in radians. So as preconditions we won't have any. We'll define that vector x here within the function. Post condition. If we want to return, x and the corresponding signs, we can. But the problem statement just mentions the plot, and so we'll just say none, and we'll make sure that we clear all of our variables before we exit. Okay. So let's start by computing or creating a vector of angles in radians from 0 to 2 times pi. Okay, so x is going to be a vector of those angles, and we're told to use Linspace. Okay, so the way Linspace works is Linspace is a function, so it's a Linspace. Okay, then we'll have parentheses, our lower bound, okay, which in this case will be 0, our upper bound, which is going to be 2 pi in this vector. And if we don't specify a third argument, what it'll do is it's going to create a vector that goes from 0 to 2 times pi, and that vector will go from 0 to 2 pi in 100 equally spaced points. If I want to change it, I could have a third argument. So if I wanted just 10 angles, it'd be say comma 10. All right, so now we're going to create a vector y, and y is going to contain the signs of those angles. Okay, and so since I want to compute the sine of each of those angles, if we stick with best practices, then it's going to be best to pre-size our vector y. Okay, so let's pre-size vector y containing the signs of the angles. Okay, and so to do that, we would do, say, y is equal to zeros. It'll have one row, and then in terms of columns, we know it'll be 100 because the length of x is 100, but to keep it general, let's just make it length of x. That way, if we were to go back and modify x, you wouldn't have to update y. Okay, excellent. So now let's set up a loop to loop over x and then store to y the corresponding sine of that angle. Okay, so let's computing sines. So we'll set up a loop for, we'll use I as our loop index variable. For I is equal to 1. Remember, in terms of a vector, the first element of the vector is 1. We want to go from the first to the last, so we'll go all the way up to length x. Okay, great. And what are we going to do each loop iteration? Well, the ith element of y will be equal to the sine of the ith element of x. Okay, so then after it finishes the loop, y should contain the sine of all of those x values. So y will be a sequence where each element of y is a sine of the corresponding element in that x vector. Okay. Next, we're asked to plot the result. Okay. So plotting. Okay, so the basic command would be just plot angle versus, so my x variables can be my angle, my y variables can be sine, so y versus x. Let's say I want to plot that as a black line. That'd be dash k. And then we can say making plot pretty. So in terms of making our plot pretty, what would we want? We want our x-axis. So to change our x-axis, it would be x label. Okay, so that's a function. The argument's a string. What would we want? So it's the angle in radians. Cool. The y label will be the corresponding sine. So we'll do sine of theta. Okay, and so then maybe what I should do here then is call this theta. And then let's print the figure so that we have a copy if we wanted to save it in a lab report. So, and just to get in the habit of, the more we use the commands, the more we'll be able to begin to recall them. So D, if you want to store as a PNG, it would be D PNG. And then we could call this, say, sineplot.png. If I want to save the fig for editing later, we could do save fig, and we could call it sineplot.fig. Okay. Let's save it. Let me call this, I don't know, sine plotter. Cool. And let's see what we have. So if I run sine plotter, oh, undefined function length. Looks like I probably have a typo. And it does. I misspelled length here. Oh, and while I think of it, we said we didn't want, so post conditions we said none. So let's clear x, y, and then while we're at it, we can clear y. And that way you make sure all the variables that we use within the script don't exist once it's done running. So try running again. Okay. Cool. See, my workspace is clear. And here's a plot of sine theta versus theta. Okay, that looks good, but maybe I want to change the x limit to end exactly at 2 pi. We can do that. So x limit we can use to set the range of our x-axis. And so let's just go from 0 to 2 times pi. Okay. Running again. All right, now it ends nicely at 2 pi. Okay. So this would be correct, but let's have a little fun and play with this just a little bit more. So if you want to cut me off here, you can, but let's keep going. All right, so Matlab does give you the ability to use Greek characters. Okay. And so the notation they actually use is the notation used by LaTeX. So if I want to actually have a character for theta, I believe it should just be a backslash theta. Okay, so let's give that a try. Hey, cool. So now I have actually a pretty theta in there. So sine theta and theta in radians. That looks good. Thinking back to what we had done before, if I hadn't pre-sized y, if I were to comment that out, and I run, my plot looks identical. I get exactly the same result. And so what happens if we don't pre-size y, then what that would correspond to is we just define y dynamically. Each iteration we would grow y by a single element. Okay. And so if I were to print that output, Let's see what actually happened. I mean, it's a matter of there's so many elements that it's tough to see, but first time through the loop, I get y is just 0, then y is going to be of length 2, then 3, and so on and so forth, all the way until it builds up to 100. Okay, so it's just defining dynamically. It works. You're not going to notice a difference in speed. Matlab gives you the little warning here. Hey, if you know the final size, it's better to precise it, which is exactly what we did here. Okay, and so what did I do? So what that tells me is, I'm going to say my plot window is just on the back, and it was. Okay, excellent. So one last thing before you wrap up, in the interest of having fun, is momentarily there's going to be a section of the book we'll come to called Spoiling All the Fun. Okay, and what we'll see in Spoiling All the Fun is most of MATLAB's built-in functions operate element-wise. So if I wanted to compute the sine of all the elements of x, I could just pass the sine of vector x. And what will happen is sine will operate element-wise. It'll calculate the sine of each element of x and then store that resulting vector to y. So if I suppress all that output, or comment out all of that, and rerun this version of sine plotter, I get exactly the same result. Okay. So we'll come back this into spoiling all the fun. Right now we're doing it the long way with loops so that you become familiar with how loops work, and these are good, simple problems to practice with. But know that in the future, it's always better to do things element-wise. MATLAB, the mat comes from matrix, so it's matrix laboratory, so it's these matrix operations are highly optimized. So if you could perform operations element-wise, you're going to notice a code improvement. Well, maybe for simple codes like this, you won't notice a code improvement, but under the hood, know that your code is operating more efficiently and better. Okay, and as we wrap up, I'm just going to restore this back to where it was. So I post the previous version along with the video on YouTube. Okay.